Now, the goal of this video is to give you a broad overview of every category that's going to be on the AP Computer Science A test. I'll cover everything from Java syntax up to object-oriented programming. So, good luck on the test. I hope you enjoy the video. Here we go. We'll start off with variables. You need to know the two types of variables. Two types are primitive and reference. We'll start with primitive variables, and the three that you need to know for the test are integer, boolean, and double. So let's declare each of these. We can say int a, that's an integer a. We can declare a double b, and then we can declare a boolean c. And that's declaration, so now let's initialize each of these. We can say a is equal to 4, b is equal to 5.5, and c is equal to false. Remember, integers can contain positive and negative whole numbers and 0. Doubles can contain any floating point number like 3.5, 4.5, any decimal. And booleans can only contain the two values of true and false. Next thing you need to know is how to make a comment. // creates a single line comment. And now let's create a multi-line comment. So we'll say line 1, line 2. If you want to make a multi-line, all you do is /* and then */. That's your multi-line. And continuing on, the next thing we have are operators. Java has an assignment operator just known as equals, and if you want to use that, all you have to say is double C, and then we can use the assignment operator to assign C the value of whatever we would like to assign it. Now, Java also has 5 arithmetic operators, and they are plus, minus, divide, times, and modulus. And these are also supported with extended assignment operators, and these are plus equal, minus equal, divide equal, times equal, and mod equal. Now, if you would like to use any of those extended assignment operators, all you have to say is just declare a variable, and let's just start this guy at 1. And then if we would like to use an extended assignment operator, let's just say we want to plus equal 2. That is really just the same thing as saying a is equal to a plus 2. And it works the same way for multiplication, division, modulus, and subtraction. And while we're on assignment operators, you should know what the increment and decrement operators are. And we'll go back to our int a example. We'll just start this guy at 0. If we say a plus plus, that is the same thing as saying a is equal to a plus 1. Now there's also a decrement operator, that was the increment operator, but we can say a minus minus, and that is the same thing as saying a is equal to a minus 1. Next thing you have to know is how to print. Use systemoutprint to print to the console, so we can say hello in here. And if I print this guy out, right there is my hello. Now if I want to do this twice, we can do this twice, and it's going to still be on one line. If you want to change lines, you can use the print line. So now I have hello on one line, and then I hit that print line, right there is my second hello. And while we're talking about printing, we should talk about the escape character. When we're printing, we always put whatever we want to print in quotes, but what happens when we encounter a problem of we actually want to print a quote? So if we want to print a quote, just use the escape character, which is \, and then you can put it right before a quote that you want to print. And if we do this, throw a semicolon on here, now we'll actually be able to print a quote, and this is called an escape sequence. \/ is the escape character, together combined with whatever you want to print there is the escape sequence. So there are a couple sequences that you have to know. One is \/ quote, another one is \n, which is just code for new line. Let's put some stuff here, and save and run. Right there is our new line. It prints ADF and then hits a new line, then goes to ASDF. You also have to know how to print a \, which is just the escape character twice. So right here's your next escape sequence. If you do \/ and then run, right there it prints one \. Remember, it's expecting that to be the escape key, so we actually have to put in twice in order to get it to print once. But now Java has 6 relational operators, and they are as follows: less than, greater than, less than or equal to, greater than or equal to for equality, and not equal to. And now all of these can compare two things, and they will always return true or false. So if we systemout.print right here, let's just say 4 is less than 5, and we can print this guy out, go ahead and run, and that is of course true. Now we can go ahead, let's use not equal to, we'll demo that guy, we'll say 4 is not equal to 5, we all know that, so let's run that, and right there is a true, yes. And we can also do comparison for equality if you want to check that one. Right there we all know that 4 is not equal to 5, so that's going to return a false. But while we're here, we should also talk about the three logical operators that Java has. Java has three logical operators known as not, and or, and I've written them in order of precedence here, where not has a higher precedence than and has a higher precedence than or. So let's get some booleans in here, and let's start out with a first system out print. First thing I'm going to do is negate a with the not operator, so we can just run this now, and we'll get a false. A is originally true, the exclamation point just negates whatever the original value is. Next we can do and, let's say a and b, where we have a true, b false, so this should return false because a and requires that both of them be true. Next let's do or, which just does the opposite. Or only requires that one of them be true in order to return a true, and right there's our true. Now remember that if you have a statement combining both of these, let's just say a or b and a, it's really evaluated like the parentheses that I'm about to throw in here. So b and a is evaluated before a or that statement. So the or will be the last operator evaluated there. And for the AP test, you also need to know the short circuit evaluation of logical operators. So let's come up here, we'll create a boolean a is equal to true and a boolean b is equal to false. And let's just system out print, and here we go. Short circuit evaluation means that if we have b and a, since b is false here and it's an and, we are not even going to check a, meaning that b is false, the expression can only be false from this point on, even if a is true, so that is it. After it checks b, it is done, it just returns false. Now it does not work the exact same way with or, but the concept stays the same. So if we system out .print, and let's say a or b, in this case a is true, so after we know that a is true, we know that the whole statement is going to be true. There's no point in even checking b. B could be true, b could be false, it doesn't matter because the whole expression is going to be true. And right there is our false, and right there is our true. You should know how to cast, and what casting does is it takes one type and converts it to another. So if we have an int a is equal to 5.5, now normally we can't just take a double and throw it into an integer, so what we have to do is we have to cast this, and casting just takes the syntax of two parentheses and whatever type you'd like to cast to right in the center. Now casting, beware, does not round, so when you cast to an integer it actually just hacks off the decimal point here, so if we would go ahead and print out a, it would just give us 5. But then you could do the same thing for a double if you wanted to. Let's say double b is equal to 5 divided by 6. If you wanted to make one of these a double, maybe to get rid of that integer division in there, you can just say double 5 divided by 6, and now that should give you a double in return, which we put into b. Let's talk about strings now. Strings are objects, although they behave a little bit like primitive variables. There's no instantiation required, but here we can make a string s, let's say hello. And then let's make a string s1 equal to by. Now, with strings, we can do something called concatenation, and concatenation is just the process of combining two or more strings. So we can say string end is equal to s plus s1. The concatenation operator is right here, it's just the plus symbol. And now if we system out print end, we're going to get a combination of s and s1. So let's print end right here, we'll print this guy out, and right there's hello by. Now, just like we have the extended assignment operators for each arithmetic operator, we also have one for concatenation. We can come over here and let's just say end, and here it is, plus equal, farewell, and if we do that, now we should get hello, bye, farewell, and right there is our printout. And now we're getting to the good stuff here. Let's start talking about single dimensional arrays. And arrays need to be instantiated, and it looks something like this. I'll just instantiate an integer array, array equals new integer array, and in the square brackets here at the end you specify the number of elements, where 10 elements, and they will be indexed from 0 to 9. Now Java is flexible about where you put your brackets, so if you wanted to say array2 and put your brackets there instead, we could do int 10 again, and everything's all fine and dandy. But now let's talk about accessing the elements. If you want to change a specific element, just square brackets, and we can say equals 5. Now we have an array with 10 elements. Index 0 is going to be equal to 5. And if you want to maybe system out print that guy, then we can say array of 0 and square brackets again. That's all we need to do. We can print 5. Now arrays also have a length public instance variable that they give us access to, and you can say system out print array and then hit your method selector. That will bring up your dialog box in Eclipse, hit length, and this will tell you the total number the total number of elements in the array. So right there we have 5, which is the element that I printed out, and now 10 is the total number of elements in the array. Always remember that the array starts with index 0 and goes up to 1 minus the total number of elements in the array. But now that last example I just showed you will take a very long time to initialize every single element in that array. So what they did is they provided us with something called an initializer list that looks like this. So if I just want to create an array that instantly has values of 1, 2, 3, and 4, I can use my initializer list here, and this line in total is going to declare, instantiate, and initialize all of the elements. Now the length of this array is however many elements you put between the braces here. So if I want to say system.out.print array.length again, then I should just get a 4 down here, and right there's my 4. But just as there are one-dimensional arrays in Java, there are two-dimensional arrays, and let's create a two-dimensional array of integers. We can do this just by saying int array equals new int with 2 sets of square brackets now. And if whatever integer you put here will be the total number of rows, and whatever integer you put here will be the total number of columns. So I said 4 rows, 3 columns, and just to help us visualize this, I've created a private helper method, so you don't need to worry about how this is working yet, but just so we can visualize, here are 1, 2, 3, 4 rows. Remember, they always start numbered from 0 to 1 minus the total number of rows, so this will be row 0, this will be row 1, row 2, and row 3. Now the columns go vertically, so this is column 0 right here, this is column 1, and this is column 2. Now there are ways to print out the number of rows and the number of columns. So if I system.out.println right here, let's say rows, the way to do this is say array.length. Now array.length will print out the number of rows. If you want the number of columns, what you have to do is say calls and then array. Now here you have to specify an index. So let's just say 0 and then put our .length. The reason for this is because we are actually getting the number of elements in a specific row. So if we want the number of elements in row 0, that will be 3, which is really the number of columns in that row. And if we print this out, right here's our printout of our two-dimensional array. Then we have rows 4, columns 3. But now, just as there are initializer lists for one-dimensional arrays, there are initializer lists for two-dimensional arrays. So if you want to do that, we can say int array equals, and now the formatting is going to be a little bit different here. We'll have one big set of outside braces, and then all the inside braces are going to represent your rows. So let's just say 1, 2, 3, and then separate the rows with commas. Then I'll hit enter. We can start our next row. Let's say 1, 2, 3 again, and comma, 1, 2, 3. Now let's end it. And we'll tab all this over, good. Put a semicolon to end the line, and there we go. Now this is an initializer list that this is the declaring, and then this will instantiate and initialize our two-dimensional array. Now just to show you, we can say print array again, and we'll print array. And right here is our two-dimensional array, 1, 2, 3, 1, 2, 3, 1, 2, 3. And now we can access elements of a two-dimensional array just almost the same way as a one-dimensional array. All we need to do is specify the reference variable name, which in this case is array, and then I'll say 0, 1. And let's just set this guy equal to 7 so we know which one it is, and then we can run again. And now we see that this guy has been changed to 7. And the way to look at this is say this is the row number, so row 0 right here, and then this will be the column number. Remember, the first column is 0, then we'll have column 1. So we went to row 0, column 1, which is this guy right here, and then we set his value to 7. If you'd like to print out a specific value, you can just do the exact same thing. Let's come down here, and then we'll systemout.println, and let's just say array of 0, 1, and now this should give us our 7 in return, and right there we go, there's our 7. And now, just to finish up our discussion with arrays, I just did two examples with a single and two-dimensional array, and I used integers for both. You do not have to just use integers. You can use any primitive or reference type. Just be aware that if you do make this a reference type, then you will have to instantiate each and every single element, otherwise you'll get a nullPointerException, and we'll talk about that more later. But now, along with arrays, we have something called an array list. And for an array list, we'll need some imports. Let's throw in our imports up here. And the way to use an array list is that you have to instantiate. On the AP test, you'll most likely see it instantiated like this. We'll just have list L equals new array list. And now for this, list is actually an interface that is defined by Java util. So this just defines the methods, and ArrayList is a class that was pre-written, and this defines how to actually implement those methods defined in the list interface. So the difference between an array and an array list is that an array list can change, meaning that we've just created an array list, and if we print out the size right here, the size is actually going to be 0. So just like an array has an instance variable to get the length, an array list has a method to get the size. So we can print this out right now, and right there's our size of 0. Now if you want to add something to the array list, you can add whatever you want. And let's just hit our method selector. Right here's the add method, and right here it expects an object. Now you can add primitive types, but it is suggested that you use the wrapper classes to do so. So let's add something like a string. So let's say S1. We can add this, and now we'll print out our size again. Now our size has been bumped up to 1. Very good. And we can keep adding a couple elements. Let's just say add. We'll say S2. And now our size should be 2. Very good. Now along with add, we also have remove. The indexes of these are just going to be the same as arrays, so whatever you added first will be 0, whatever you added second will be index 1, and so on. So we can say L.remove. This is going to expect an index here. Let's say we remove 0. Now the nice thing about this is now our size is down to 1 again. Now it's going to remove this guy. It will automatically bump this guy up to the first position. So if we just want to print that out and make sure that it actually bumped him up to the first position, we can use what's called get, and that's going to expect an index here. Let's say get whatever is at 0, and now this should print out S2 for us, and right there is our S2. Now there's a nice simple way to print out our array list, and that's just by printing out whatever the reference variable is. So let's just print out L, and let's get rid of this remove statement so that we can see both of our elements in there. If we print this guy out right there, we have our S1 and our S2, again index 0, index 1. Very nice. Now another method that you should know is the add method that takes in 2 parameters. So we can add, let's say add 0, we want to add S3. If we add S3 at index 0, then we're going to get a printout that looks like this, where right there's our index 0, and notice that it's pushed these to the next indexes. So now we have 0, 1, and 2. Very nice. The next one that we should know is L.set, and what set does is we can specify an index. Let's just say 1, and we want to set it to new val. And let's run that now, and now we have 0. We've taken 1, replaced it with whatever we said right there, which was new val. Another thing that you need to know about array lists is that we can specify a specific type that we want to allow in the array list, and you can do this here, do it in both the declaration and the instantiation. And once you do this, then it's saying that this array list can only take in strings. If we try to throw anything else in this array list, then we're going to be flagged by the compiler. So let's just say L.add, and let's try and throw an integer in here. Now we're going to be flagged because this does not match the type that we've designated in our instantiation. And now you may be saying, well, what if I want to put a type in here that's a primitive type? Well, they actually create something called a wrapper class. So let's say we want to just only allow integers in here, and we can do so. So let's say only integers. And what integer is a wrapper class that will hold a primitive type of integer. So we can say integer I equals new integer, and then in the parentheses here we can specify whatever integer we want to instantiate. And let's just do 5, and then we can say L.add, L is our list, remember, and we can say L.add I, which is our integer. Now we should all be fine and dandy, and we can system.out.print our list again. And if we print this guy out, right there's our list that only holds integers of 5. And now another wrapper class that you should know is the double wrapper class. Same thing, just a wrapper class to hold primitive double types. But now let's say you wanted to create a list that can hold absolutely anything. Well, at the base of the Java hierarchy, meaning at the very top of the Java hierarchy, when you create a class, everything extends a class called object. And now this is the same thing without adding this type parameter. It would automatically do this, but I'm showing it explicitly here. So if we say we want to only allow objects in here, then you can literally throw anything that you want in this list. If you want to add an integer there, we added an integer. Let's say you want to add a string, and let's just say hello. Everything's all fine with that. Get rid of my extra parentheses here. Because object is at the base of the Java hierarchy, every single class will extend the object class, or will be the subclass of this object class, meaning everything is an object, so everything can be thrown into this list here. Before we move on, I'd like to mention one more thing. I'd like to talk about this import statement up here. You do have to know the format of the import statement for the AP test, which is just the package name and then period and then the specific class that you would like. So here they have the Java util package, and then we are importing the specific class, or in this case the class ArrayList, and then the interface list. And there's a class in the Java standard library that you should know how to use, and that is the math class. So math class, you can literally just say math period, and then it'll bring up a list of methods that you can use. Now, if we want to use some of these, let's just say math period. One of the good ones is max, and we can just specify two numbers in here. Let's say 4 and 5. If we run this, we of course know that 5 is the max of 4 and 5. And there's also a min that does the exact same thing, but how about another one that's called square root. Let's take the square root of 16. Right there's the square root of 16. We can run this, and of course it's 4. Now the last one I'd like to talk about is absolute value. So we can just say ABS. Let's put in -5. We know that the absolute value of -5 is of course 5. Now the math class also specifies a couple constants that are very nice, so we can actually access pi if we wanted to. Right there's pi. We want to print out pi. There's a nice printout of pi. Okay, now it's time to get in the good stuff. We finally reached control statements. So for control statements, we'll start with the if statement. So I'll bring my booleans back here. And right here is the if statement. It takes the syntax of if, parentheses, and then some boolean expression in here. I'm going to use booleans. You do not have to use booleans. If you wanted to put, say, 4 is less than 5, or x is less than y, or two variables in there, that would all be fine. So now the way this works is that we can put a print statement or any number of statements in here, and let's just say reached here. So if A is true, then we'll execute all the statements in here, and we can run this and say, yes, it's reached here. But if we put B in here, which is false, and we run this, now since this condition is false, it's going to skip all the statements within the brackets and then head down below it. Now, you do not need brackets with these for most of the control statements in Java. You do not need brackets if you do not want them. The only condition is that if you don't have brackets, it will only include one line. So here, everything's all fine, same thing happens, but it will only include this line. Be careful if you do not include brackets. If you have brackets, you can include as many lines as you want, provided that you put all of the body statements within the brackets. Now, along with the if statement, there's something called the if-else statement, which means that if we can just have a condition that says if this one isn't executed, we want this one to be executed. And same bracket rules, so we can just say reached else. So now since B is false, we're of course going to skip this guy. We'll go straight into the else. We'll run here. Right there's our reached else. And along with the if else, there's also an else if, which is really just chained if else statements. So if we want to here, we can say else if, and we'll take in another condition. We can say, oh, I don't know, not B, and we'll add brackets here. Let's just print 2 so we know where we're at. Now the key here is that only one of these will be executed. Because of the format of the else if this one is executed, it will actually skip this entire chain now and just go down below this else and start executing the statements down here. Same thing if it hits either of these. If it hits the else if, it will not execute the else. Think of this as one unit. As soon as one of these is executed, it skips down below and will start executing all the ones below. So now right here we have if B, which is false, else if not B, so we should hit this statement and we should not hit the else. This should print 2, and right there is our 2, of course. And the way I have this set up now, it will actually never hit the else just because of the B and the not B. And now we're on the repetition statements. Repetition statements repeat a block of code over and over and over. So let's say int x is equal to 4, and we can say while x is less than 10, and let's just come down here and we can put an increment in here. We'll say x plus plus and then just add a print line just to show what's happening. So the way this works is we'll have x is equal to 4. We'll come down here and say is x less than 10? Well, x is 4, so yes, it's less than 10. We'll come in here, we'll print x, then x will be incremented to 5. Then we'll say is 5 less than 10, and we'll keep doing this until it reaches the value of 10, at which point 10 is not less than 10. It will break out of this loop, and it will come down here and continue the rest of the code in this main. So let's run this. Right here is our printout. We have 4, 5, 6, 7, 8, 9. 9 is the last value that will come in here, print out. It will get incremented to 10, and then that will stop our loop, and that is the while statement. One thing you have to be careful of with the while statement is running into an infinite loop, and the way this works is that if you don't have an increment in here and x constantly remains 4 and this condition is never false, then it's just going to continue executing this statement forever and ever and ever. So let's hit run, and now it's still printing 4, printing 4, printing 4, and we can stop it just by hitting the red square here. But that is something called an infinite loop, and you want to be aware of that. And now we're on to the for statement. The for statement is basically the exact same thing as the while statement, except it's going to take the three main parts of a loop, which are initializing statement, condition, and update statement, and it's going to put it in one nice line. So we can say for int I is equal to 0, I is less than 5, I plus plus. Notice that these are all separated by semicolons here, and then we can put brackets, same rules for brackets. If you have brackets, all lines inside will be included. If you don't have brackets, only one line. Now let's throw a print line in here, and we'll print line I, print this guy out, and right there 0, 1, 2, 3, 4. The way this works is that we initialize I to 0, we'll come in here, execute all the body statements, we print out our I, which is 0, come back around to the top of the loop, then the I++ is hit, so really this is hit at the bottom of the body statements. Then we'll check the condition and say I is less than 5, which it is, and then we'll keep going until the condition is set to false. Now, one interesting thing about the for loop is that you actually don't need to put anything up here. I have my initializing, and then my condition and my update statement, but if you wanted to get rid of all three of these, you could actually do so, but the semicolons are required. If you just put 2 semicolons, all the syntax now is fine, so let's just print hello, but this is just going to be one big infinite loop, and there we go. So you can actually omit whatever you would like here. If you just want an update statement, you can put that in. If you just want an initialize statement, that's fine too, and just a condition, that's fine too. But you do need the semicolons. And the next thing we're on to is the enhanced for loop or the for each loop. For this example, I'm going to create a list. Right here's my list, which I have deer, duck, and buck added. Now I'll create my enhanced for loop, and I'll say for each string in string s in list, I'm going to print each of these out. So system out.println, and I'll just print s. The way this works is that this has to match the type of what you're looping through. So I'm looping through a list called list, which only has strings. Here I've said it can only contain strings. So I'm going to say for string s, where s is just a variable that you define, I'm going to loop through, and then I'm going to print out each s in that list. And if I run this, right there is my deer, duck, and buck. And now, just as you can do that for a list, you can do it for an array. So let me get rid of this. We'll put an array in here. Here I have an array of integers. So instead of a string here, I'll just put integer. We can put integer I just like matching. And now we'll say array. And let's just print out each integer in there. So for each integer I in array, which is my array of integers, I'm going to just print it out. And right there we have 1, 3, 4, 5, which is each element in our array. Now, while we're here, we should also talk about how to loop through an array with just a regular for statement, and all I'm going to do for that is just say int I is equal to 0, I is less than. Here I can put an array.length, and I'll say I++. Now inside of here, I can just put a system out print line, and I'll say array of index I, because that's my variable that's going to be constantly changing. So we're going to start at I, which represents my index, as 0, because 0 is the first element, and we'll go up to just before the length of the array. So if we run this, then this should do the exact same thing I already have, which just prints out 1, 3, 4, 5, which is nice. And now, of course, if there's a way to loop through a one-dimensional array, we can do it for a two-dimensional array. So let's get our two-dimensional array here. And right here is our two-dimensional array, 1, 2, 3, 1, 2, 3, 1, 2, 3. We are going to loop through this guy. Instead of using I this time for my variable, I am going to use row. So I'll say row is equal to 0, row is less than array.length, because that's my number of columns. I'll give a row plus plus. Now I'll use my brackets this time and say int call is equal to 0 for my next one. And we'll say call is less than array. And now here I can specify an index, but I'm just going to use that row variable that I just created. And then I can say call plus plus and put another bracket here. Now I'll use my systemout.print line, and if we just want to print out every single element in here, then we can just say array of row call, which is beautiful because of our variable choices. So now if we want to print that out, right there is 1, 2, 3, 1, 2, 3, 1, 2, 3. If you actually want it to look like a two-dimensional array, all you need to do is make that guy a print, and then add a systemout.print line right here. And let's do this. Maybe we'll throw in a space right here just to make things look nice. And if we run right there, we have our original looking array. We should also talk about how to loop through a two-dimensional array with a for each loop or an enhanced for loop. And to do this, all we have to remember is that a two-dimensional array is really an array of arrays. So we can say for a two-dimensional array, we'll say rows in array, put our bracket again, and then we'll say for each int I in rows, put our bracket again, and now here we can just put our system out print just like last time, and now we don't even have to specify indexes. We can just say I, put it in our space, come down here, do the exact same thing, put our print line in again, and right there we go. Now when we run this, right there's our exact same printout using a for each loop or an enhanced for loop this time. Alright, and now we've hit the point where we know most of the basic Java syntax, and it's time to get into the object-oriented aspects of it. So let's close our demo here, and now I'll have two classes that I'm going to be working with now. One is called tester on the right here, which just has a main, and then I have another one on the left here called human, which will be our class template that we'll start working with. Now, on the left here, we're going to create the class human template, which means this is nothing more than a template for creating a human object. So once this is fully created, we can come over here then and instantiate a new human, and we can make the human have whatever we want. Whatever variables we want, we can put in here. Whatever we want the human to be able to do, we can also add over here. So let's just start, and we'll start by adding some private instance variables. At the top here, let's just say our human is going to have a string name, and then we'll also give him an int age. So right there are two variables that this human is going to have. The next thing we want to add to our class template is something called a constructor. And we can just start this by saying public, and then this has to be the name of our class. In this case, I'm not going to put any parameters, and in here, a constructor is designed to initialize the instance variables. So our two instance variables are name and age, and we'll just initialize these to the empty string for name. We'll say he has no name, and we'll set his age to 0. And really, at this point, now we've done all we need to do to come over here and instantiate a new human. So what I'm going to do is say human age equals new human with no parameters in there, and now I've just instantiated a new human. This is called a reference variable. If we wanted to, we could just declare a variable like this. Now we've declared a variable of a type human, which we've just created. But now if we want to instantiate, we say equals new human. New is an operator which triggers the constructor. So then we come over here, as soon as this is hit, then it comes over here to the constructor and executes all the code in here. Just to prove this to you, I'll throw a system out print line in here. Let's just say constructor here. And now as soon as I run this over here, we should be able to run, which will cause our constructor here to be executed, and we'll hit that systemout.print. Now the reason this is called a reference variable is because it references the location of the object in memory. Instantiation creates an instance of the class, of the human class, and then the reference variable knows the location of that object out in memory somewhere. And the object really just contains all of the instance variables that we've made. So as soon as this is instantiated, memory is reserved for each of the instance variables, and now this knows the location of that object out in memory. While we're here, we should talk about the difference between public and private. We made our instance variables private because we don't want to give our client, the tester over here, access to them. we want to force the client to go through the methods that we provide. And although we haven't provided any methods, I just want to show you how you could access these variables. Right now, if I hit H and then hit my method selector, I have everything that I've already inherited from the object class. Remember that the object class is at the top of the Java hierarchy, so just by creating the human class, I am already a subclass of the object class. But now I don't have access to anything that I've actually created over here yet. If I want to have access to something over here, I can just create it as public and then come over here, hit H, hit my method selector, and right there is the name that I created over here. Now if we were going to allow the client to do this, then they could come over here, say H name is equal to Butch if they wanted to, and now they would have direct access to that variable. But I don't want them to be able to do that, so I'm going to change this back to private, and we'll leave our instance variables as private. Now in Java you can have more than one constructor, so now let's make a second constructor that actually takes in some parameters. And here what I mean by parameters are things in the parentheses here that can be passed when you instantiate. So for this I'm going to take in a string nm, and then I'll take in an int ag to represent my age. And now inside of here all I'm going to do is just pass that straight to my instance variables, age and name. Now what this allows us to do is now that we can instantiate both a human with no parameters, but we can also instantiate a human, let's say h1 equals new human, and now we can put some parameters in here. So let's say Tyler, and then let's also say 35. Now everything should be happy. We can create a new human with two parameters in here that must match exactly what we created in the constructor. Now as soon as this is instantiated, it's going to check what parameters you used. Here I used one string and one integer, and then it's going to find that constructor in the class template, find the one with a string and an integer, and it will execute all of the code in here. So now as soon as I did this, Tyler gets assigned to my instance variable name, and 35 gets assigned to my instance variable age. And we'll keep rolling. For now, we always want, for what we're doing at least, these constructors to be public. So remember that these two are your constructors here, and I'll copy and paste that and put a comment right beside this guy just so we remember that's our constructor. Now the next thing we want to do is we want to start creating some methods. So a method is just going to look something like this. We'll say public string get name, and then inside the method we'll have a return statement that's just going to return the name. Now this method that I just created is called an accessor. Now all an accessor does is it accesses the value of one of the instance variables. So we have an instance variable named name, and now all we're doing is going to return the name. And I'll show you what a return statement does now with our client. What a return statement does is if we come over here and systemout.print h1, now we should have the getName method that we just created, and here it is. And it says that we're going to return a string, and when we print this now, it should be printing the name of h1. In this case, it is Tyler, and if we run, right there is our constructor here. We can see that it hit our constructor, and then we also printed Tyler. But now, let me kill this print line here, and we need to talk about the structure of a method. So the method starts with a visibility modifier, which is going to be public or private, depending on if you want to give the client access to it. The next thing will be a return type. This return type has to match the return statement, meaning that if I'm saying right here that I'm going to return a string, then this return statement has to match exactly and has to return a string. If I would have tried to return age right here, then the compiler would get mad at me because my return statement does not match my return type. So let's put this back to name. The next part of our method is going to be the name of the method, and you can specify whatever you want here, but the method name should follow this capitalization rule, starting with all lowercase, and then the first letter of each following word is going to be capitalized. And we'll keep moving. The next thing we want to do is create an accessor for our other instance variable. Notice that this one is an integer we're returning, so all I did was change the return type. Next type of method we need to talk about is a mutator, and the mutator is going to have a void return type, and a void return type just means that you aren't going to return anything. And then we'll say set, and now we can do a set name, and then we'll take in a parameter as a string s, and then we'll say name is equal to s. The way this works is that a mutator is going to change the state of a variable, or the state of an object. So we have a string name, and then what this is going to do is that we can come over here to our client, Let's say we want to change the name of h1 and we want to change it to h1 set name to Charlie. If we want to change the name to Charlie, then that's no problem, and we can come over here and run this again, and now our name is Charlie when we call h1.getName. There are a couple other things we need to talk about with methods. For methods, they can be public or private, just like our instance variables, although our instance variables should always be private. If I wanted to make this guy private, I can do that. Now I'll save, and notice I'm being flagged by the compiler because h1 no longer has access to the setName method. Let's change this guy back to public. The next thing we need to talk about are method signatures. Method signatures include the name and then number and type of parameters. It does not include the return type. The AP course description is very specific about that. It says that a method signature includes the name and the number of type of parameters. For example, the setName method is called setName, and then it takes in one string. When using a method, just the same thing as a constructor, when you use it, it has to match the number and type of parameters. If I would have tried to throw an integer in here, I would have been flagged by the compiler. And the last thing we'll do to this class is we'll throw one more method in here called the toString method. ToString method is a special method, meaning that as soon as you print out a reference variable, it is going to grab the toString method and execute whatever code is in there. So if I just wanted to print out h1, I could come over here and do that. Let's run that, just see what happens. Now right there is my human, Charlie, age 35. Because it executed all the code in my toString, which says human, grab my instance variable name, grab my age. Now the toString method gives us the perfect chance to talk about something called overriding. We override a method when the method is also located in the parent class. As I said before, the human class is automatically extending or is the subclass of the object class. The object class already contains the toString method. So when we write our own toString method with the exact same name and exact same amount of parameters, in this case none, it is going to override the method of the parent. So rather than doing what the parent class has, it's going to come into ours and then do our own toString method, and that's what overriding is. The next thing that we need to understand are subclasses. So I've went ahead and created this class athlete now, and what we're going to do is make the athlete a subclass of a human. So every athlete is a human. All we need to do is just say extends human. Now this line right here has made athlete the subclass of human. Now athlete, due to a process called inheritance, is going to inherit everything that we already wrote in the human class. Meaning athlete will already have a name and an age, it will already have a get name, get age, set name, and a toString method from the human class. Now let's start creating our athlete class. The only real difference here is that we're going to add a sport variable now, so an athlete will have a name, an age, and then we'll have a specific sport for the athlete as well. Let's create our constructors. We'll create the athlete constructor, and we'll create one that takes in no parameters. Once we do this, we can use what is called super. Now super references the superclass, in this case human. So when we call super, we're going to call the super constructor here, and now whatever parameters we put in here will determine what constructor is used. So in this case, we're just going to call the super constructor with no parameters, and it'll initialize the name and age of an athlete to no name and 0. And then the last thing we want to do is just set our sport equal to the empty string here, and now we have a no parameter constructor for athlete. Now, a small side note about using super: if you do choose to use it, it must be the first line. Notice that I just switched those and I'm immediately flagged by the compiler. But let's go on and we'll create our second constructor here for the athlete class. This one will take in multiple parameters. So for the first one, we'll say string name, and then we'll take in an integer ag for the age, and finally a string s for the sport. We can again call super. This time we'll take in multiple parameters. We'll say super nm and ag for our string and for our name and age. And when we do that, that will automatically call our second constructor of the human class and execute the code within here. Now the last thing we can do is just take our sport variable, assign s to it, and there we go. We just finished out our second constructor for the athlete. And let's just finish out the athlete class here. Right here's my accessor for sport. There's my mutator for sport. I've also created another toString method. This is another example of overriding because we're overriding the toString method of the parent class human. And then also I'd like to point out one part of this here. If we use super and then hit the method selector, we have access to any of the methods that we've gained through inheritance, meaning we've gained the getName method because we're the subclass of human. Now we have the ability to call that method directly just by saying super period getName. Then I just finish it out with a comma and then the sport that the athlete plays. Okay, now we've hit the point where we can actually instantiate an athlete, so let's go to our main again. And I'll get rid of everything we had before, and now let's actually instantiate an athlete. So we'll say athlete A1 equals new athlete, and here I am going to put some parameters. I'll say name is Spike 35 and he is a bowler. Now let's just go ahead and we'll say A1, hit our method selector. This is going to show us all the methods that we have access to. Notice that we have the getName and getAge methods that we inherited from the human class. Even though we did not write the getName and getAge methods over here in our athlete class, we still have access to them because of the process of inheritance. Remember, if you are the subclass of something else, you automatically inherit all the methods from your parent. So now the last thing I'll do for you here is we can just system out print, and we'll print A1 here just so you can see the toString, and right there is my athlete Spike and he's a bowler, as I said. Now there are some interesting things you need to know about instantiation with subclasses and parent classes. Now that we have our human and athlete classes completed, we can actually say, if we wanted to, human h1 equals new athlete, and then we can put the same parameters in here, and the compiler is completely fine with this. The reason is because an athlete is a human. An athlete is a subclass of a human, so this is perfectly fine. The only thing that h1 is limited to, though, is that it can only use methods of the human and object classes. Here, if you look at all the methods it has access to, only human and object classes are there. Now, if we would want it to have access to the athlete class, we could cast. So let's just cast h1. And now when I hit my method selector, there we go, there are my athlete methods. Now the interesting part about this is that if we would choose to print out h1, let me just comment this out so there's no discrepancies, but if we would print out h1, remember this is going to call the toString method, and I can even put toString here, although it's not required, but it is going to go to the toString method, and this is the class that provides the implementation. So although it is declared as a human, it's going to go to the athlete class for the implementation, and I can run this and we'll see that it still prints athlete Spike bowling. Now, one thing you cannot do is that you cannot go the other way. If you wanted to say athlete A1 equals new human, you would be flagged, because not every human is an athlete, as we all know, but every athlete is going to be a human. Think about it in terms of the hierarchy. Human is above athlete, therefore it's fine to say human h1 equals new athlete. But athlete is below human, so this would be going back up the hierarchy, which is illegal. Now the next thing that we're going to go into are called abstract classes. Abstract classes are just the same as the classes we just made, except abstract classes cannot be instantiated. So I went ahead and made human an abstract class here. The only thing that I did was typed abstract right in the class header. And now if I try to instantiate a human, let's just get rid of the end here, and we'll type human h1 equals new human, which we know should be able to be instantiated if it were a regular class. But now that it's an abstract, we're getting flagged, and all this is going to say is cannot instantiate the type human, and that is because we've made it an abstract class. Now the other thing that being an abstract class allows you to do is that you can define abstract methods. So if you want to define an abstract method, it's going to look something like this. We could say public abstract int age in dog years. So age in dog years is going to be a method that's going to be required to be written in the subclass. And also notice that there's no implementation for the method here. I simply just ended this with a semicolon. There are no brackets. The only thing I did really to make this an abstract method was just add the word abstract right before the return type. Now that we've saved that, you can see that I'm automatically being flagged over here, and the error says type athlete must implement the inherited abstract method. So in order for this error to go away, we have to come over here and say public int age in dog years, and all I'm going to return is return super.getAge, and then we'll just multiply it by 7 to get our age in dog years. Now our error has gone away and everything's happy because I've implemented the abstract method that we inherited. Now that's it for abstract classes, and the next thing that we're going to go on to is interfaces. Right here is a public interface person. The only thing that an interface can contain are method signatures. So here are my method signatures for getName, getAge, setName, and setAge. And rather than extending human now, what I'd like to do is take our athlete class and implement the person interface. Now what it means to implement an interface is saying that I have to have every single method signature defined that is in that interface. Now that we're no longer extending the human class, there are a couple things that we'll have to change. First, we'll have to add those variables back in. Right here's our string name that we did inherit before, but now we'll have to have it in this own class. So then we'll also add our int age, get rid of all of our super calls, and we can get rid of age and dog years. And now let's just paste all those methods that we inherited from before, and now everything's happy. We implement and we define every single method that is inside the person interface. We implement that interface, and now we have a class that implements an interface. And the last thing I'll do here is get rid of this super call down at the bottom. We'll replace this with name. And now let's go over and start instantiating. So we'll get rid of all of our humans, and now we can actually say person p equals new person. Now this is a problem. An interface can never be instantiated. An interface only has method signatures, so there's no real reason that we would ever want to instantiate it. But what you can do is you can use person p and then instantiate any type that is implementing that interface. So we can say new athlete here, and we'll use the no parameter constructor. Now one thing that you do have to be aware of when doing this is that you only have access to the methods of this interface. Meaning that if I come here and hit P method selector, now the only thing I'm going to have access to are methods of the object class and the person interface. I do not have access to the methods that are written in the athlete class. For example, getSport is right here. Even though it's written in the athlete class, I don't have access to it because P was declared as a reference variable of the person type. Again, if we wanted to, we could cast this guy to an athlete, and then we would have access to the athlete methods. Now to finish out classes, I'd like to briefly talk about variables. These variables at the top are considered global instance variables, which means they're instances of the class. They are created when an object of this type is instantiated, and they can be used inside any single method in this class. Notice that I've used age and name in many different methods with no problem. Now, a local variable is considered a variable that's declared inside of a method. So if I created an int I right here, that's perfectly fine. That's a local variable to that method. I could also create an int I down here with no problem. So that's a local variable that only exists within these brackets. Now there's one more variable, and we need to talk about scope, which scope is where a variable can be used. But the last one is, let's say we declare an int j inside a for loop here, and we could finish this out if we wanted to. But then let's create our brackets for our for loop. J only exists within the brackets of this for loop, and we consider j to have block scope. So we have j that has block scope, and then we have variables declared inside methods that have local scope, and then we have our instance variables that have global scope. To finish up this athlete class, I'd like to add one more thing, and what we're going to add is a private static int count, and we'll set that guy equal to 0. Now what this is this is a static or a class variable. This means that we no longer reference an object if we want to get to this guy. We have to reference the class, meaning athlete. So let's just create a method that goes along with this, and you can also create static methods. Just like you can create a static method that goes along with a main, you can also create static methods in a class. So let's say public static int and then get count. And now we'll just return that count variable. So the only thing our count variable is going to do, it's going to count the number of instantiations of no parameter instantiations that we have. So let's put a count ++ right here, and now we can go over to our tester and instantiate. Let's get rid of this instantiation. We'll replace with 3 athlete instantiations. And now let's make a call to that static method that we created. So we now reference the class rather than a reference variable, and we'll say athlete period get count. This will create a call to that static method we created, which then uses the static variable we created, and this gets incremented every single time it makes a call to this constructor. So we should have 1, 2, 3. Let's print this out, and right there is our 3. One more thing on variables, I'd like to come over here and create a public final static int, and then we'll just call it var is equal to 500. So now I've added the prefix final, which is just going to say that var is equal to 500 and it will always be equal to 500. In fact, if you tried to change this, you would be flagged by the compiler. Now it's static, so again, we can just access it by referencing the class name, hitting period, and right there is var. So if we print this guy out, that'll be our 500. Another vocab term that you'll need to know for the AP test is overloading. Overloading is when you create a method that can accept different types of parameters but has the same name. So let's just say we created public void print something. And now let's say we wanted to print something a number of times. And we could put in some implementation in here, but just for demonstration purposes, we'll leave it blank. Now let's say we create another method here called the exact same thing, print something that takes in a number of times and times 2. And again, no implementation. Now we say that the print something method has been overloaded to accept different types of parameters. Even though it has the same name, we can still call it and throw in one integer, we could throw in 2 integers, and everything will be fine because it's been overloaded to accept different parameters. Let me delete my overloaded method here, and now we need to talk about javadoc comments. Javadoc comments start with / 2 stars and then hit enter. This automatically brings you into the javadoc comment. Now let's do it on one that actually has some parameters here. So we'll come up to our constructor, start our javadoc comment. Notice that it automatically has tags here, and these tags are for each of the parameters. Now you don't have to write any of these, but you do have to know what they mean. So after each one of these, if I choose to describe the parameter, that is what it is for. So I can say this is the name of the athlete. And now when they give you a method on the test, they're going to expect you to know what @param means. So all it says is @param, this is a parameter, and right here is that parameter, and then this is a description of it. If you want a description of the actual constructor, you can put that up here. So describe here. Now this is used to create an HTML file, which can then be used to take a look at your class. But again, you don't have to generate that, you just have to know how to read these. The other one that you'll have to know is a return. So let's come down here to one that has a return. Let's put our javadoc comment in. Right there is our return tag. And again, right beside this, you would just describe the return. So this returns the sport. And right there's the sport. So when you see the @param and @return tags, know that it's just describing what those things are going to do. Now let's bring up our main again, and for this I would like to now create an array of athletes. As I said before, you can create an array of any primitive or reference type. So athlete is a reference type, and what we're going to do is say athlete, square bracket, and we'll say array is equal to new athlete, square bracket, and in here we'll put 10 and semicolon. Now we've created an array of athletes. As I said before, you have to instantiate each and every element. So let's just say array of 0 is equal to new athlete. Now that I've done this, array of 0 is going to have access to all of the methods from the athlete class, and there they all are. If you would try to access a method without actually instantiating it, so let's say we try to do this with number 1 here, then you're going to get something called a nullPointerException. So let's say get name, which is a method of the athlete class, and now let's go ahead and run. And right there is our nullPointerException. A nullPointerException occurs when you try to send a message to a reference variable that isn't connected to an object. Here, array1 hasn't been instantiated like array of 0 has been, so you're going to end up with that nullPointerException. Continuing with exceptions, you should also know what the arrayIndexOutOfBoundsException is, and this occurs when you try to access an element in an array that doesn't exist. For example, our array is 10 elements long. We're now trying to access index number 11, and let's just instantiate this guy like we did above, and we'll save and run, and there is our arrayIndexOutOfBoundsException because 11 does not exist. And there's one more simple exception that you should know. This is just the arithmeticException, which occurs when you try to do something that's illegal in the math world. So right here, let's just do 5 divided by 0, and we can run this guy. Right there is our arithmeticException, and it'll even say divide by 0. And to finish up here, we'll talk about a few more things with strings. One of the things we need to talk about is the equals method. So we can say system out print, and we can say s period equals s1. Now this is different than the equals equals relational operator. This operator compares two objects to see if they exist at the same place in memory. This compares two strings to see if they are exactly equal. So now let's run this. Right there we have a false. It's going to return true or false depending if these two strings are exactly equal. And one more method that you need to know is the compareTo method, and we can just put compareTo s1 right here. Now the compareTo method is going to return 0, a negative number, or a positive number. And the way it works is that we're going to start at s1 and say how do we get to s. So we start at c and say how do we get to a. Well, it's just minus 2 in this case. So we can run, and right there is our minus 2 because a is 2 before c. Now compareTo is based off of the ASCII table. Each letter is assigned a number value, so funny things will happen if you change from lowercase to capitals. So capital C has a different ASCII value compared to lowercase c, so now if I run this we're going to get a different value here. Just be careful when you use the compareTo and note that capital letters will be different than lowercase letters. Now, that about does it for all of the testable language features on AP Computer Science A. Some things I didn't cover that you might want to look into are recursion, linear and binary searches, and the sort algorithms are also on there. You need to know insertion, selection, and merge sort. But that does it for me. I hope this video helped. Post any comments or concerns. If you need clarification on anything, let me know. I'll do my best to get back to you. Hope you enjoyed the video, and good luck studying.